So let's do the toString function really quick, and then test out what we have. So public string, toString. Okay. For right now, I'll just return table.entry, well, tables is an array, so to turn it into something readable, arrays.toString entry. Or arrays.toString table. And that's going to, but I'll show you. That's not all we have to do here, because here, hash map, there's actually a lot we have to do here. Hash map, this is my hash map, map is equal to new hash map of string to integers. It doesn't really matter the type right over here, but if I were to say sout map at the moment, okay, there's a couple things we need to notice here. First, it's going to produce a whole lot of nulls over here. Okay, it's going to produce a whole lot of nulls. We don't really want those nulls to appear. We'll deal with that later. We don't want the nulls to appear because what we would like to see is that this is empty, right? So just, you know, open brace, close brace if we want to embrace this. Second thing we probably need to see is that map.put, I'm going to put hello, actually jello for once, and 2. And then here's our issue. We see I put that in, that maps correctly, and it gets inserted here, but we see null, 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 hash map entry, which isn't very useful here. So what we need to do is we need to actually have another toString method for our entry class over here so that it will render fine. So public entry. I mean, we can handle it in the toString method, but honestly, this is easier for testing purposes. Because what the array's toString does is that it says, okay, we're going to build this thing, and then we're going to call toString on each of the objects in the array. So we will just simply do public string toString. Okay, remember this is the entries toString method. Return. And here what we want to return is key. Let's go with key colon space plus value. And that should, let's see how that looks over here. Jello 2. Okay, not too bad, actually. Let's go ahead and just, yeah. Let's just do it like that. No space. We don't, okay. There we go, Jello 2. And that works right now. So we're going to go ahead now and finish writing up this guy. And then we'll work on the toString method. So here we can put an object in here, no problem. Jello to hello. And our hash code function figures out where we should put our thing, you know, where we should put our thing. Hello 3 and Jello 2 and sout map.size. So here, see, we replaced the old hello with 3, Jello with 2, and we're still at size 2, which is great. Okay, so now we need to see if it's gotten filled up. So if capacity is greater than or equal to, if size divided by capacity is great. So if we found an empty space, first thing we want to do is see if we have enough space to put it in. So if size divided by capacity they're both ints, so that's going to be a bit of a trick. So if 1.0 times size divided by capacity is greater than or equal to 0.75. And why did I multiply by 1.0? That was to turn size into a double. And then it will be a double divided by an int, which will turn this into, which will yield a double, right? Because otherwise I'll get 0 as my answer, and that will never be greater than, not 0.75, but greater than max load. So if we're at max load currently, if we right, there's no need to rehash if we just hit it. But if we hit that load, that max load, then we need to rehash our table. So if adding this basically exceeds our, if we're at our capacity, then let's rehash before we put it in. And why am I doing this before as opposed to after? Because I don't want to have to put this in twice. Okay, so rehash. Obviously, it doesn't really matter. So let's go ahead and create a new method over here. Private void rehash. And this will look like it's potentially like kind of recursive or infinite loopish, but it won't be because, well, this condition will only be true once. You'll see what I'm talking about in a second. Okay, so the first thing I need to do is I need to say that capacity is now equal to 2 times. So first thing I have to do is say size is equal to 0. Okay. Set the size equal to 0. That sounds really, really weird, but I have to do it this way, just because the only way I'm going to be easily able to add everything back in to this is by calling put from rehash, which calls rehash. But to make sure that I don't call rehash again and kind of get into an infinite loop situation, I have to do it like this. So capacity is equal to twice the capacity, so we're going to double our capacity and then add 1, because that's more likely to be a prime number. And prime numbers, as you'll see, really good at avoiding much better at avoiding collisions than having not prime. So size is equal to 0. The capacity is equal to twice the capacity. Okay. E table. So first off, E entry array old table is equal to the current table. Store that there. And table is equal to new entry array of capacity. Okay. So we've doubled the capacity, reset the size, moved all the items over here, and what we're going to do is basically, essentially what we've just done is that we've removed all the items from the table. Right, table's now blank. We've removed all the items from the table, hence size being equal to 0. And now what we're going to do is we're going to go through the old table and put all the old items in. So, for int, for int I is equal to 0, I is less than old table dot length, I plus plus. If old table dot, if told old table index, sorry, old table I equals null. So if there's nothing in that, so we're going to check each spot in the table. If there's nothing in that spot, guess what we do? We just simply go on, continue, because there's nothing to add. Otherwise, what do we have to do? Entry key, key is equal to old table I dot key, get the key. What's the issue here? Incompatible types. Oh, right. Totally forgot my generics over here. K, V. So key V value is equal to old table I value. And then what do? We do table.put. Or rather, we call this dot put key value to put that back into to put it into the new table. And okay, so the new table's twice the size. We've already upped the capacity, so when we go back into here, capacity, we're not going to hit this condition again, guaranteed, because our capacity will have doubled, and that will make it impossible for that to be to hit this condition again. And then we don't have to worry about changing the size or resetting the size manually from 0 to the old size, because adding these guys will take care of that for us. Okay. So go through it, add everything in. That will add everything to the table. Okay. So first, just make sure I didn't break everything horribly there. Okay. So let's go ahead and do something rather boring here, but we're going to double check to make sure this works. So, okay, what we're going to do is do for I is less than 20, map.put, let's do a, the character a plus I, that'll be an integer, plus LO. Okay. So what I'm doing over here is I'm taking this combination over here, car I. So this will basically be this over here, A will should get translated to, let's try this with just 5 units first. Okay. Sout map. Hello, bello, cello, dello, illo. Okay. Right. All this does is that this takes a plus 0, a plus 1, a plus 2, which turns the character a into an integer. I believe so. 97 plus 0, then 98 would be b, and then returns and then casts it back into a character. So just simply hello with different starts. So we're going to test this out and fix out toString in the next video.